Hello everyone. In this session, let's understand how to find the absolute value of any given number in ARM7. But what is this absolute value and how do we find it in ARM7? Absolute value means the magnitude of a number, ignoring its sign. If you consider the number minus 10, the absolute value of this number would be 10. At the same time, if you consider plus 10 also, the absolute value would be 10 itself. So now let's see how we do it in ARM7. We are using a pseudo instruction LDR in order to copy our actual data whose absolute value is to be obtained into register R0. Next, what we are performing is comparison. We are comparing R0 with 0. So what this will do is it will perform R0 minus 0, and from that we will obtain our result as R0 itself. But based on this particular result, the CPSR conditional flags will be updated. Those are nothing but negative, 0, carry and overflow flags will be updated. Next thing we see is branch if greater than or equal. This particular conditional code will check if n is equal to v. That is, either both are equal to 1 or both are equal to 0. In that particular case, branch happens. See, we have kept this condition here because if n is actually equal to v, it means r0 is greater than or equal to 0. In that particular case, we don't have to make any change. We have to just jump to stop, which is nothing but an infinite loop. It keeps jumping here, stop branch to stop itself. And if that is not the case, then we have to perform a reverse subtraction between r0 and 0. Why do you think this is done? What will reverse subtract do? In case of reverse subtraction, instead of r0 minus 0, we perform 0 minus r0 and store the result in r0. If r0 is a negative number, then what will happen? Then 0 minus of, like in this particular case, minus 10, the result is plus 10. That is what we are trying to do here. Now let's see how this particular code works. But before that, what are these? These are nothing but assembler directives. If you notice here, we have something called area, which defines a section in memory. It's named as ABS, that is, that section of memory is named as ABS, and the reason this particular section of memory is defined is to store this particular information, but this information are nothing but actual instructions, so it is called as code, and it is read-only section of memory because we don't want any modification to be happening to this particular code. Entry indicates where exactly execution should start. After entry, the very first label you see is the location where execution actually starts. End indicates the end of source file. Okay, so now let's see if there are any errors in this particular code and proceed with debugging. As we can see here, there are no errors, so we'll go ahead with debugging. So now let me perform step-by-step execution. Here I can see when I perform load operation, R0 is stored with all F's and 6. Why is that the case? We know 1010 in binary is your decimal number 10. So what is minus 10? Perform 2's complement on that. What will be the result of that? That will be nothing but minus 10. So how will you obtain that? See, even if I write 1010 here, it's actually all zeros in the higher position and the last 4 digits will be something like this. If I want 2's complement, how am I obtaining that? I need to get 1's complement of this and then add plus 1. Okay, so how will I calculate 1's complement of this? I have to flip all the bits, that is, find the complement of each bit here. So this is the 1's complement of this particular data, and when we add 1, what will happen? This 5 will become 6. So what is this? F, and this is nothing but 6. Okay, that's why minus 10 is written as all F's and 6 here. Okay, so next thing that we are doing is we are performing comparison. Let's perform that, and let me open this. Okay, you can see NZCV is initially 0. Let's see what happens when I perform comparison. Minus 10 minus 0, answer is minus 10. It's a negative value, so N is set as 1. But since overflow is not generated, we can see it is set as 0. Okay, so in this particular case, N is actually not equal to V, because of which this branch will not occur. Instead, this subtraction will occur. Let's see that happening. So this got ignored and we are going to perform reverse subtraction, and the result you obtain in R0 is now A. So as expected, we have obtained the correct answer. Now let me change this. I'm taking a positive number. Now let's see what will happen. Here the value 10, that is A in hexadecimal, is loaded into register R0. Comparison is done. As you can see, N equal to 0 and V equal to 0. So here, because of this branch will occur, and we have already reached the infinite loop. So that's all about this code.